In this video, we're going to talk about the 5 main ingredients that you need in order to generate a thunderstorm. Now, I want you to look at this checklist as almost like an ingredient list, like if you were going to bake your favorite baked good, or if you were going to just make, let's say, a bunch of chocolate chip cookies. Well, what are the main ingredients? If you were going to make chocolate chip cookies from scratch, what would you need? Well, you would need eggs, flour, sugar, chocolate chips, especially if you were making chocolate chip cookies, and an oven to bake it in. And you would need a couple of other ingredients, but those would be the basic ones. So just like when we talk about thunderstorms, you don't necessarily need all the ingredients, but the more ingredients you have, the more severe weather you can actually obtain. And you can actually use this checklist when we talk about the formation of tornadoes, since tornadoes really only spawn from severe thunderstorms. So when we talk about a severe thunderstorm, that means that we have a lot of ingredients, and therefore we can get a very severe system. So the first thing, when we look at our checklist, the first thing that we need in order to generate a thunderstorm would be energy. So we need some type of energy to generate these powerful storms. And when we talk about energy in the atmosphere, we talk about heat energy, and we've talked about heat energy a lot. But when we talk about thunderstorms, we talk about what is called CAPE, or convective available potential energy. And convective available potential energy is the amount of heat in the atmosphere that can be used in order to trigger thunderstorms. So remember the difference between potential energy and kinetic energy. Potential energy is energy that you can use later on, or has the potential to do work later on, whereas kinetic energy is in the process of doing work. So the first thing we need is energy. Typically, meteorologists, when we forecast for thunderstorms, is that we want to look for at least 500 joules per kilogram of CAPE. And so a joule is a heat unit, so 500 joules per 1 kilogram of air. So that's what the units would be. So there's ways to look at this on weather maps, and I'll show you that in another video. But typically, 500 joules per kilogram will get you some kind of decent thunderstorm, also depending on what else is going on. But 500 joules per kilogram is the absolute minimum. When you start getting into the thousands, like 1,000 to 2,000, that's when we talk about severe thunderstorms. Anything really 2,000 to 3,000, now we're talking about severe weather, and that's pretty much almost tornadic kind of CAPE values. So just to kind of give you some numbers just to wrap your heads around, at least 500 joules per kilogram of CAPE is needed in order to generate a normal thunderstorm. The second thing that we need is we need some type of trigger. We need some type of lifting mechanism that will force air to rise. So this can be any one of the 4 main ways to force air to rise. So we can either get orographic lifting can cause thunderstorms. Oftentimes it's a frontal boundary or a cold front, sometimes even a warm front or a dry line, but it's some kind of frontal boundary that will cause thunderstorm development. When we talk about Florida in the summertime, that's because of the convergence of the 2 sea breezes. So when we have sea breeze convergence, that can be another way to force air to rise. So there are these different triggers that can cause air to rise. And if you don't have a trigger and you don't have any way of forcing air upwards, then you can't have a thunderstorm. The third item that you really need in order to have a thunderstorm is what we call wind shear. Now, wind shear is a change of wind speed and or direction with altitude. And so when we talk about wind shear, imagine that you have a pen in your hand and it's laying flat on your palm. And then what I want you to do is to take your other hand and I want you to roll it over the pen. So why is the pen rolling? Well, because your hand on the bottom where the pen is resting is not moving. So it's at a wind speed of 0. When your top hand is moving, okay, it's moving at some speed. Okay, let's call it 5 miles per hour. Let's just put a number on it. So when the pen rolls, that's because it's a difference in speed between your bottom hand, which is at 0 miles per hour, and your top hand, which is at 5 miles per hour. So that's why the pen rolls. So it's the same mechanism in our atmosphere. When we talk about wind shear in this case, and when we talk about thunderstorm development, we're talking about a change of wind speed with altitude. And that becomes very important, especially when we talk about the longevity of thunderstorms. When we want thunderstorms, or when we look for thunderstorms to last a long time, or even on the time span of a couple hours, or even up to an hour, something that's really not like a 10-minute thunderstorm, we're looking for a decent amount of wind shear, because what this is going to do is it's going to create a sort of horizontal roll. As you see in the bottom right picture, here you can see the wind speeds at the surface are light, but the wind speeds aloft are very fast. So what that does is that creates this rolling motion. And so when we have this rolling motion, we have some circulation in our atmosphere. And when we have this circulation in our atmosphere, what it does is that it helps separate the downdraft from the updraft. And what happens is that if you have decent enough wind shear, you can actually have a very nicely separated updraft and downdraft. And that's important because if the updraft and the downdraft are not necessarily tilted or they're closer together, what will happen is that cooler air will leak into this warm conveyor belt that is the updraft sooner than later. And so once that happens, cool air gets caught back into this thunderstorm, and then the thunderstorm dies out because the thunderstorm needs a lot of heat. So when we talk about wind speed values, typically we like to see 30 to 35 knot wind shear. So mean to say there's a difference between upper level winds and lower level winds that equal out about 30 to 35 knots. Now, the last two items you don't necessarily need, although it helps. So number 4, we want to see a weak cap, meaning to say we don't necessarily want to see any kind of strong inversions in our atmosphere, because that's what's going to do is it's going to prevent air to rise. And if air cannot rise, then convection can't happen. And if convection cannot happen, then we do not get a thunderstorm. So if we have a very strong cap, then that means that air will not rise. So think about a water bottle. If the cap is on the water bottle, what happens? Well, the water doesn't spill out. It's secure within the water bottle. But if the cap is loose or it's not tightened correctly, that's how water can leak and water can escape. So oftentimes in the summer, in the morning, there is some type of weak inversion that basically gets eroded by just solar daylight heating. Another way that you can actually get a cap to weaken would be from some kind of frontal passage that moves through. So let's say in a situation where it's very, very hot, you have a lot of energy in the atmosphere, you have a lot of moisture, you have a lot of the ingredients already set in place for thunderstorm development, but what you have is you have a strong cap that is keeping air from rising. So on a typical day, what happens is that in the early morning hours, yes, we do have this little capping inversion. So we have a layer of cooler air above warm, moist air. So what happens during daylight heating is that we have the convection that normally occurs, which basically helps to erode the capping inversion. So once that happens, once air is fully free to rise, it does so, and that's how we typically get convection. So another way that capping inversions can affect thunderstorm development is that if we have a strong capping inversion where normal daylight heating and convection isn't enough to break this cap. So if that happens, then thunderstorms, even though you may have all the ingredients, thunderstorms may not be able to occur. So that'd be like saying you had all the ingredients necessary to make your favorite baked good, but the power went out and you were unable to use the oven. Therefore, it didn't matter how many ingredients you had, you still were not going to produce any type of baked good. So when that situation occurs, what you need is you need some kind of trigger, or you need some kind of front to actually move through the region, and that will help remove the cap, so therefore air can rise. And typically when that happens, you get very explosive thunderstorms. And the last ingredient that you need is humidity. Especially if you want a lot of rain in your thunderstorm, humidity is key. Remember that humid air is less dense than dry air. So when you have hot and humid air, typically that's found in a maritime tropical air mass, that means that you have very unstable air already that is very eager to rise, and all it needs is a little push some kind of trigger or something to force it to rise, and therefore you will generate or begin to develop convection. And so those are the 5 main ingredients that you need for thunderstorm and tornado development.